Number 1, quiz review, or then we're taking our quiz. What would these angles add up to? All right, so I'm going to add right now 155 plus 75 plus 2. See, that'd be 232. So 16x plus 232 is equal to 360 degrees. You would subtract 32 from both sides. 16 times x is 128. Divide by 16. And I think that goes evenly 8 times, correct? 128 divided by 16. I should see your reviews on your desk. I don't know why I don't see some people with their reviews. It is 8. Okay. Remember, doing this right now will help you do better on your quiz. If you have done it, then I hope you're checking your answers. Okay, number 2. If you have the central angle is 115, then its intercepted arc is also 115. So 23 times x equals 115. Did somebody need something? All right, so we divide by 23 and get 5. Okay, number 3. Find the circumference. Circumference is pi times the diameter. You should probably have that memorized at this point. The radius here is 2, so what's the diameter? Okay, double it, 4. So our circumference is pi times 4. We grab a calc. We use the pi button on our calculator, and we hit times 4. Rounding to the nearest tenth, that would be 12.6. The label is centimeters. Okay, number 4. It's already giving you the diameter is 14, so the circumference is pi times 14. That should be one of your fastest problems ever. Pi, oops, I don't know where didn't hit my pi button. Second, arrow up, that's your pi button, times 14. We got 43.98. If I'm going to the 10th, then I need to round the 9 up to a 0 and the 3 up to a 4. So it'd be 44.0. And that's in centimeters. Okay. Number 5. It says, if an angle is given, name the arc it makes. Well, this isn't actually a major arc, so I crossed that word out. I don't know why they had that major arc listed, because a major arc is more than 180. This is a minor arc. The arc that angle 3 makes is arc VT, and you put an arc symbol above it. Or arc TV, I don't care which way. That's all they're asking for. Number 6, what's the angle? If the arc is CD, what angle made it? Angle 1. The one that intercepts the arc. Find the length of the segment indicated. All right, now we look at this diagram. If you see a number like this outside of the whole diameter, it's meaning the whole diameter. If it meant the radius, it would be this little one right here. Okay, they'd make it more clearly a radius. So if you know the diameter is 24.2, what is the radius? Okay, dividing by 2 gives you 12.1. Well, if that's 12.1, this is 12.1 then. Both of those are radii. We want to find x. Is x part of a radius? Yes, it is. That's the center of the circle. So I don't know why, but I feel like sometimes we don't see other radii because of, it just looks different because it's got some segments running through it and stuff, but this goes from the center to a point on the side, which makes it a definition of a radius. So this whole thing is 12.1. So all we got to do is do 12.1 minus 6.8, and that'll give us x. Because x plus 6.8 equals 12.1. So I don't care how you look at it, you can write this equation. You're going to subtract 6.8 and get 5.3, right? Yep, 5.3. It doesn't give us a unit, so 5.3. Done? All right. Next one. This is also a radius from here to here. It's asking us what the diameter is. That's worth 2 radii. So I can figure out the radius right here. 5.2 plus 7.6 is 12.8. That is a radius. If the radius is 12.8, how big is the diameter? 2 times 12.8, 24, 25.6. Bless you. Or X is 25.6 units. Sorry, that was X, which was a diameter. Okay, number 9 wants us to find X, but now I don't, it's a radius, but I don't have another radius given. So since I have a right triangle here, then I can use Pythagorean theorem. X is a hypotenuse, so X squared equals 7.6 squared plus 9.7 squared. You grab your calculator, 7.6 squared plus 9.7 squared. I'm a little slow there. You get 151.85. Now, what do you got to do now? Take the square root, okay, of 158.85. So I'm going to hit second X squared, put in 151. Actually, you could have put in that answer, but I'll type it out. 151.85. And that comes to 12.3. All right, so X is 12.3. That would be the radius of that circle. Right? Number 10. Find the length of the segment indicated. This is X. This segment right here is 15.1. Since this is perpendicular, that chord got bisected. So this would be 15.1. Now, I've got a right triangle. This is a leg and this is a leg. So X squared plus 15.1 squared equals 17.1 squared. So what I need to do on my calculator is do 17.1 squared minus 15.1 squared. I know I got to subtract, so I'm just going to do it. 17.1 squared minus 15.1 squared. I just did that instead of writing down all those icky numbers. So I'm to 64.4, and that's X squared equals 64.4. We got to take the square root now. And I don't like that it says round to the nearest tenth. A lot of stuff we were rounded to the hundredths because this isn't exactly 8, but it comes out to 8.02, or doesn't it, on your calc? So we would have, if we said to the 10th, the choice, it would be multiple choice, would be 8.0. I think 8.02 is a better answer, but that would be to the hundredth place though. All right, 11. Now we're messing with the arc measure. It says find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. All right, well that means I definitely got some diameters in here. It says DCF. I start at D, I go to C, and then to F. So I want this angle measure right there. Well, I'm going to need this, aren't I? I need that plus the 59. How am I going to get it? Well, D to G is a diameter. So let's figure out D to E by doing 180 minus 41 minus 59. Or if you added 41 and 59, that's 100. So when you do that 180 minus that, you're going to get 80. So then I got to go, okay, well, I want angle DCF, so I need to add 80 and 59 because the exterior arc measure in degrees is equal to the central angle. So the measure of that angle is 80 plus 59, which is 139 degrees. Okay. Number 12 is the measure of the arc IKH. I go from I, then there's an H here, but I can't go that way because I got to hit K before I hit the H. So I through K all the way to H is everything on the circle except 35. So I'm going to do 360, which is all those added up, minus 35. And I believe that's 325 degrees. Good. All right, next we've got GEH. So I started G. I got to go through E and end up at H. Does somebody see something we could do quick? Ooh, good, Olivia. That's what I want to hear. Vertical angles, because see, that's 66. This is 66. Remember, the angle is equal to the measure of its central angle. The arc is equal to the measure of its central angle and vice versa. So if that's 66, this is 66. And now to find that whole thing, I just do 360 minus 66, because that's 66. Okay, so I 360 minus 66 is 294. Good. All right, next, 14. Find the measure of the arc or central angle indicated, HEI. HEI. Oh. Well, I was thinking maybe we need to use that 118. So I was going to look at what makes the 118. You see this? So this is an arc that's 118, and this would also be 118. You see the vertical angles? All right, we want to know HEI right there. So we're just going to do 118 minus 40. It's not the only way you could get it, but it's the easiest way. It'd be 78 degrees. Question? All right, 15. Find the length. Now, arc length is x degrees out of 360 times pi times the diameter. It's in your ISN. You get to use it, but it's really not that hard to remember. Take the angle measure, 45 out of 360 times the circumference of the circle, which is pi times the diameter. They gave me the radius is 18, so what's the diameter? 36, 2 times 18. So you're going to do 445 divided by 360 times pi times 36. Okay, that gives you 14.1, and that would be in feet. Did I type that right? Is that what you guys got? Yes? All right. Now, my 16 is different. You've got 13 right here, I believe. Correct? All right, so 120 out of 360 times pi times, is your 13 a radius? So what's the diameter? That'd be 26 then. All right, so you want to put 26 in your formula, not 13. So 120 divided by 360 times pi times 26. Got 27.2. Okay. I don't know. It said to label it. I don't really. Oh, what was it? It was in inches, right? Okay. And then 17 just is the same problem, except we don't have a picture. So if the radius is 5, the diameter is 10. And now you just do 75 out of 360 times pi times 10. Okay, what is that? Somebody finish it for me. 6.5? What? Yeah, you guys got 6.5? Okay, thank you. Meters. And then the last one here, I think you have a radius of 11, correct? So diameter would be 22. So 270 out of 360 times pi times 22. Don't forget, you use the diameter, not the radius. Find the diameter by doubling the radius. Okay, I wanted to briefly mention just a couple more things, because that's just a repetitive problem. If you have a chord and there's a radius drawn that is perpendicular to it, what does it do to that chord? bisects it. All right, so this is cut in half. What about the arcs? Like if this is 120, how big are each of them? This cuts it in half, all right? Just want you to remember those will be cut in half. Also, if I asked you to find this, and I told you this was 6, and I said the radius is 10, what would you do? Draw in a radius that might be on there. I don't even remember if it for sure is, but it's a good question. Draw in a radius. This would be 10, and then you would do the Pythagorean theorem to find x, okay? And let's say you had a clock. What if I told you that I said, what's the length of the arc formed by the hand going to, and say this was, I don't know, 140 degrees. Then you're just going to don't make it like it's a harder problem than it was, because you're just going to do 140 out of 360 times pi times the diameter, right? So it's the same type of problem, like if I gave you that this is 10, or again, the radius is 10, then you would do 140 out of 360 times pi times 20, okay? So it's a part of a clock, big deal. All right, and then the only other thing I probably would say is like if you have a circle and you have a right triangle inscribed in that circle, how are you going to find the diameter if, say, this was, I don't know, I'm just making up numbers. How are you going to find the diameter? You would do Pythagorean theorem. Okay, let's do this